I've got a challenge for you. Imagine a water slide where the path changes every time someone goes down. 3 beavers have already gone down this water slide. Each one changed the slide in a different way. Now it's Beaver's Dan's turn. But where will he end up? Hello, I'm Mariah, and today we're going to solve this Bebras challenge called the Exciting Water Slide. And trust me, this is no ordinary water slide. At the top of the slide system, there are special forks that control which direction a beaver goes. But here's the twist. Every time a beaver goes through a fork, the direction flips. So if the fork points left, the beaver goes left. And then the fork switches to the right for the next beaver. If it points right, the beaver goes right. And then it switches to the left. And so on. Quite fun, right? I told you this was no ordinary water slide. I kind of wish they had a slide like this at the water park I used to go to when I was younger. Today, little beaver Dan wants to try the slide. But his mom wants to stand at the right exit slide so she can take the perfect photo. You know how moms are. There are 4 exits. Slide A, Slide B, Slide C, and Slide D. Before Dan goes, his mom watches 3 other beavers come down. The first beaver exits from Slide B. The second beaver exits from Slide C. We don't know yet which slide the third beaver will exit, but Dan will be the 4th beaver to go down. So here's the question for you. Which slide will Dan come out of? Will it be Slide A, Slide B, Slide C, or Slide D? When I was younger, I was the kind of kid who loved puzzles and logic games. This type of challenge reminds me exactly of those games. I used to sit with a piece of paper and try to trace every path possible until I figured it out. Pause the video here and try to work it out yourselves. Okay, let's solve it together. Remember, every time a beaver passes a fork, that fork flips direction. So when the first beaver exits at Slide B, we can figure out which directions the forks must have been pointing. To reach Slide B, the beaver must go left at the first fork, then right at the second fork. But after the beaver passes each fork, both of those forks flip direction. So now, the first fork points right, and the bottom left fork points left. We still don't know the direction of the third fork yet. Next comes the second beaver, who exits at Slide C. By tracing that path, we see that he first goes right, and then he goes left. This means that the first fork now points left and the bottom right fork points right. So now we finally know the direction of all the forks. That means we can also trace the route the third beaver takes, and then deduce the exit direction of all the forks afterwards. The beaver first goes left at the first fork, which flips it to point right, and then the beaver goes left, which flips the fork to the right. So the third beaver exits at Slide A. Now we know the direction of all the forks just before Dan slides down. Let's see which slide Dan will slide down by following the current directions of all the forks. Dan travels through the slide system and ends up at Slide D. So the correct answer is Slide D. Mommy beaver better run to that slide to get that picture. This challenge is actually a simple example of how decision-making works in computer science. It is similar to how conditional statements work in programming. A typical conditional statement follows the pattern: if a condition is true, do this. Otherwise, do something else. In this challenge, we can describe the fork behavior like this. If the fork is pointing left, the beaver turns left and the fork switches to the right. Else, the beaver turns right and the fork switches to the left. Each fork also remains in the current direction it is pointing to. In computer science, we would store this kind of information in what we call a variable, which simply keeps track of a value that can change over time. For example, we can use 0 to represent left and 1 to represent right. As the beaver moves through the structure, a program could check the value of the variable, which means the fork's direction, decide which path to take, and update the variable to reflect the new state. As more beavers go down the slide, the forks keep changing direction. To figure out the final outcome, we follow the process step by step, just like programmers do when they trace through a program, to understand what it will do. This kind of thinking is an important foundation for understanding algorithms and programming. And finally, this mechanism is also similar to a flip-flop in digital circuits, a basic unit that stores one bit of data and toggles between two states. Each fork behaves like a flip-flop, switching its state every time it is used. Thanks for watching and exploring this Bebras challenge with your students. If you try this activity in your classroom, we would love to hear your opinion about it. Please feel free to share your experiences, ideas, and suggestions in the comment section below, so that other teachers can learn from them too. And if your students enjoyed this challenge, encourage them to share their thoughts and solutions in your Microsoft Teams class chat. It can be really interesting to see how different students approach the same challenge. Thank you for helping us bring computational thinking into the classroom, and we hope to see you and your students in the next challenge.